Good morning, everyone. Thank you so much for tuning in. Good morning from San Diego. Good afternoon, good evening to wherever you're tuning in from. We're very excited to be here today to talk about how you can extract insights from your unstructured data using our latest capability, BYO-LLM, with NVIDIA GPU acceleration with open source Hugging Face models on VantageCloud. I'm very excited today because we have a special guest joining us, our amazing product manager for ClearScape Analytics and BYO-LLM, Jefferson Uwe. Jefferson?
Hi, good morning, everyone. Thanks, Janet. Hi, everyone. It's great to be here today. We at Teradata, Janet and I will walk through how Teradata makes it easier to bring open source language models into your enterprise stack. And together, we'll be able to show how it is performant with secure and flexible, the ones that you expect from Teradata.
So let's dive right in. We'll begin by first discussing the different challenges that our developers face when they're building and deploying AI applications. We will then introduce Bring Your Own Large Language Models to talk about how this new capability solves these various challenges using open source language models and NVIDIA GPU acceleration. We will then dive into a demonstration where we will showcase how you can begin building your inference pipelines with VantageCloud using open source Hugging Face models and NVIDIA GPU acceleration. Specifically, we'll be working with an entity recognition model. Stay tuned because at the very end, I have a nice little sneak peek for what's coming next with our Teradata GenAI package that streamlines the entire process that you are about to see, making it easier for our developers to build, experiment with, and deploy various language models. If you have any questions at the end of today's session, please feel free to drop them in the Q&A chat section, and we will answer them at the end of the session. So let's dive right in. We'll begin by discussing the different challenges that different industries are facing today. Organizations across different industries of all sizes are feeling increased pressure to deploy AI applications, whether it's to gain a competitive edge or to meet business demands, or simply to operationalize to streamline their operations. The reasons are various, but what can't be avoided is that AI is necessary. And this pressure trickles down to our developers who have to face questions and challenges. How do you, as a developer, select the right language model to work with? Do you opt to work with a task-specific language model or a larger, more robust large language model? How do you avoid moving large data sets that are costly and can take a lot of time? How do you ensure you provide security and privacy for your data when you're building these AI applications? These are all questions and challenges that Bring Your Own Large Language Model capability is solving. Jefferson, can you explain to us how BYO-LLM solves these various challenges for our developers?
Yes, sure, Janet. Bring Your Own Large Language Models, or BYO-LLM for short, is Teradata's way of giving developers more control of their AI solutions. As you can see on the screen, there's a few points I want to make here. So here's what the first point is: Bring Your Own LLM enables seamless integration of open source large language models from Hugging Face by letting you run them inside your VantageCloud environment. Second point, there's no data movement. So if you're running all this inside the Vantage, you don't have to export data to another platform. So which means less cost to you and minimal compliance risk. Everything happens where your data resides, securely and at scale. And third, and last but not the least, is you also get GPU's acceleration, making inference lightning fast. In our labs, we've experienced or we've seen up to 200 times faster inference than CPU. All of this means you can experiment freely and quickly with the confidence that your data is secure and your job will run fast and will scale. Janet, can you tell us why Teradata has brought open source language models to VantageCloud?
I sure can. We're noticing an interesting shift in the industry. A research paper published by DeepMind found that smaller, compact language models, when they are trained on larger data sets that are domain specific, these smaller language models can outperform your more robust large language models on various tasks. And as a result of this paper, we are seeing an explosion of the small, compact, task-specific language models being developed and made available to everyone. Now, don't get me wrong, large language models are still dominating the AI industry. However, these small task-specific models are perfect for our enterprises who want more accuracy, cost control, and performance. And thanks to Hugging Face, we have an ecosystem of open source models that our developers can select from, experiment with, build with, and deploy. For those of you who are not familiar with Hugging Face offers a repository of open source transformers or models for various text, audio, and video processing. Developers can select from task-specific models and large language models. And now, as a recap for the key difference is that language models are specialized on a specific task, whether it's sentiment analysis, entity recognition, or masking personable identifiable information. While large language models are larger, more robust, they have millions of parameters, they do require GPU acceleration. These models are often known as your generative AI models. And at Teradata, we support all options. We enable our developers to easily select from open source task-specific language models or open source large language models. And we also allow them to work with their preferred CSP provider hosted language models, whether it's AWS, Microsoft, or Google's language models. Jefferson, can you review with us the three different patterns that we support, the different design patterns that we support?
Yeah, certainly. So before we begin the demo, allow me to show you the three patterns of language model inference in Vantage. You will see the three patterns you see on the screen. In no particular order, these three patterns provide flexibility to use the latest models that fit your AI use cases. To your left, you will see the first pattern. This is the one that Janet is going to demo today. With this, you are able to bring your own choice of domain-specific language models to conduct text analysis on your data that reside in Vantage. This includes sentiment analysis, text classification, text summarization, and more. This is made possible through Teradata's Open Analytics Framework, together with Teradata Gen AI library. It's a Python library we just released a month or so ago, and the cloud service providers' GPU accelerated instances. And so language model inference is as easy as a few lines of Python code with Open Analytics Framework. The second pattern is shown here in the middle. Is available for users who want to run inference using large language models offered by cloud service providers. The cloud service providers that we offer at Teradata is AWS. They have AWS Bedrock, Azure OpenAI, and Google with Google Gemini. In this case, users can use their own CSP account to securely run inference with Vantage data. And the third pattern on the right is a variation where on some Vantage platforms where you don't have GPU acceleration available, you can still run language models and do inference using Hugging Face models. These Hugging Face models run on CPU by taking advantage of Vantage AMP parallelism, right? The models in this case must be in Onyx format. So there you go. There's the three patterns that you should be, we want you to be familiar with. And today's demo will focus on the first pattern. We will show you how you can deploy open source language models to your Teradata VantageCloud environment. Let's move on to the demo. Janet, will you provide some information before you start the demo?
I sure can. Thank you so much for that recap, Jefferson. It's always great to see that Teradata offers various options for our developers to solve different challenges. In today's demo, I will be showcasing how BYO-LLM and NVIDIA GPU acceleration with Hugging Face open source models work inside VantageCloud. It's a simple 3-step process. We will connect through a Jupyter notebook to our VantageCloud environment. We will then upload artifacts into our user environment that is powered by our analytic GPU compute clusters, and we will inference using we will apply a query to inference using our open source models. So yeah, that is what we will be seeing today. Let's get started. You can access this demo at teradata.com/experience. Here you can create a free account and sign in. Upon signing in, you will be taken to this dashboard where you can quickly spin up VantageCloud environments and begin ingesting and transforming data within these VantageCloud databases. You can also build, deploy, train, and monitor your AI models. For this demo, however, we will select the Run Demos button, which opens up a hosted Jupyter Lab environment, giving you access to over 200 Jupyter Notebook demonstrations across various industries and cover various use cases from predictive AI to generative AI, agentic AI, and advanced analytics. For today's session, we have prepared a very special demo that you can access by navigating to the VantageCloud Lake directory and select the Entity Recognition subfolder to find the Entity Recognition Jupyter Notebook demo. Within this demonstration, this unstructured text analysis, we are really highlighting how data scientists and developers have full control over the models and analytics they deploy on GPU-enabled clusters using Teradata's Open Analytics framework. Today's demo, the demo that we have prepared for today, showcases a sample use case in the wealth management industry. Now, I will skip to some of the cells that contain the data that we will be working with. We've preloaded a OFS table called Financial Entity Dataset with call center summary information. Now, these summaries reflect your typical advisor-client conversations about investments, retirement plans, and financial products. What we will do here, we will use our open source task-specific model for named entity recognition, the Roberta Large, onto Notes 5 that will help us extract key phrases such as the client names, the financial institutions, key dates, financial products, and even geographical entities. This NLP task can help financial firms quickly automate meeting note tagging for faster documentation and regulatory compliance. It can enhance client profiling by identifying frequently discussed financial topics. And all of this will be conducted within our VantageCloud environment without moving our data. And we will be using open source models and GPU acceleration, which gives our teams full control, flexibility, and scalability. Great. Now let's go back to the very beginning to explain how we can connect and execute these cells. As mentioned, this notebook is readily available for you to preview the code. However, if you want to execute the cells and experiment with additional NLP tasks and open source Hugging Face models, please send an email to support.clearscapeanalytics@teradata.com, and our team will provision your ClearScape Analytics environment with the required permissions for Open Analytic Framework. The first thing that we do in this demonstration is install the required dependencies. These are our Teradata ML Python package, the latest version, are transformers and torch packages, as well as other libraries. Once these libraries are installed and your libraries and modules are imported, you can proceed to establish a connection to the VantageCloud Lake system that has Open Analytic Framework access. In this instance, we're working with a lake environment. We use the create context to establish this connection and pass in our credentials. As mentioned, once you request access, this environment file will be created for you. The next thing we want to do after we set our engine is authenticate into our user environment services to manage our containers. The user environment service allows us to use APIs to create containers and manage them. These custom containers are persistent, meaning they're created once and can be reused as needed. To do this, we will need an Open Analytics endpoint, an access token, PEM file, and we will need to use the setAuth token function and pass in these credentials. Now, as mentioned, when your request for Open Analytic Framework has been granted, these credentials will be automatically provisioned for your environment. However, if you have access to a VantageCloud system with Open Analytic Framework, you can access these credentials and objects via your console. And I will share where you can find this in the VantageCloud Lake console. You will sign in with a user that has console access, select the environment that you want to work with, and you can find the host name under the Connect Your Tool section of your environment's dashboard. This is the IP address to the VantageCloud system. And this reminds me that you need to have your administrator whitelist your personal IP address so that you can communicate with this IP address for your VantageCloud system. The next item that you will need to establish user environment service authentication is your Open Analytics endpoint, which will grant you the ability to create custom containers in Open Analytics Framework. You can find this right underneath your hostname, and the final items that you need are your personal access tokens and your PEM files. To retrieve these, you can navigate to the user profile icon, select account settings, and scroll to the bottom where you will see access tokens and keys. Select create and proceed to follow the instructions to create your access token and your key files. Download and save them for future use. The final item I want to highlight is our need for an active GPU analytic compute group. And if you would like to create an analytic GPU compute group, you also need to log in as a compute group administrator. If you're signed in as your compute group administrator, you can select this Create Groups button, input a name, a description, and select the group type as Analytic GPU. Once your analytic compute group is up and running, you can proceed with the demonstration. And as mentioned, once you have access, this GPU compute group will be up and available for you to execute this NLP task. Once your authentication has been successful, you can then proceed to prepare your container for model deployment. The first step I would recommend, and I have listed some methods and APIs that you can use to explore managing your containers. For example, the list user method will search and list any available user environments that you may want to reuse. You can use the getEnv API method to retrieve and work within that environment. I want to also demonstrate how you can create a new environment. The first step involves listing the available base images within your VantageCloud OAF system. Once you list those base images, you can then proceed to use the create m API method and pass in your environment name, the base environment, as well as the description. Once your user environment has been created, you can then install your dependencies. For our specific NLP task, we are installing our transformers and torch dependencies for our Hugging Face models. Notice how I have set the asynchronous call to true, because this step might take anywhere between 2 to 5 minutes depending on your network. And that's one of the reasons why I am reviewing the already executed cells. Otherwise, it might take a while to do this live. Okay, so once your libraries have completed installing in the environment, you can also use the .libs method to list all the libraries and dependencies that were installed into your custom environment. Once your libraries have been installed, you can prepare your open source Hugging Face model for entity recognition and upload it to the user environment service using the APIs. First, you would download the model into your local system. Here we're downloading our named entity recognition model, and we are then compressing this model into a zip file. Once your model has been compressed into a zip file, you can then use the install model method to upload it into your user environment. Once your environment is ready with dependencies, with the model, you can proceed to create the Python script that will inference against your unstructured data in VantageCloud. This script will read text from our input table using the standard input. It will use our open source Hugging Face model to perform entity recognition and will output our extracted entities in a structured delimited format. Once our Python script for entity recognition is ready, we can then install it using this install file method. And then we're ready to run our apply class to execute the script against our dataset. Before we do that, I would recommend that you set the session to a specific compute group, GPU compute group that you may want to use. Otherwise, it will default to any available GPU compute groups. And if you don't have one up and running, you will get an error when you execute your apply statement. And finally, here is where it comes together. We instantiate an apply class with our dataset, our script, our environment, and within seconds, once we run it, it inferences inside our user environment using our GPU compute cluster, and results are returned in a data frame. We've essentially just done an in-database inference with a Hugging Face model without moving the data. Now notice how we're using a general purpose named entity recognition model, which has been trained on, I believe it's on 2 nodes 5 data, which identifies entities such as org, person, dates, product, and geographical locations. The product entity refers to physical items, not financial items. So for finance-specific tagging, you'd most likely want to fine-tune the model with domain-specific data to get better results. Now, I have provided additional natural language processing models that you can experiment with here. I would encourage you to request access to run this demo and play around with text classification, language detection, generating embeddings, and other NLP tasks. To make this process even easier, Teradata offers the Teradata GenAI Python package, which wraps the setup process into just a few lines of code. We can now create an environment, install your model, and execute NLP tasks with high-level functions. Let me walk you through how this simplifies the entire process. In the example notebook, you will install the Teradata GenAI Python package and import modules, the Teradata AI module and Text Analytics AI module. The Teradata AI module will handle the download and installation of Hugging Face models into the user environment, while the Text Analytics AI module will give you access to any of the NLP high-level functions. In the example notebook, we will remove the user environment we created at the start of the demonstration, and we will recreate it just to compare the process. We will validate that the environment was in fact created, and then we will define the model. We will pass in our model arguments and initialize the Teradata AI class. Upon initializing the Teradata AI class, this will kickstart the download process and installation into our user environment. We then install our libraries, and we will configure our Text Analytics AI object with our language model, which will allow us to run named entity recognition using that high-level function. You'll notice that this will also automatically upload 2 default scripts into our user environment. These are used by default for inference and embeddings, but if you want to use your own script, you can upload it and reference it with the script parameter. We then are ready to inference using our recognize entities function. We pass in our data set, we specify the column where our unstructured data resides, and we also pass in a custom script. We defined our returns object, and that's it. Inference runs just like before, but with fewer lines of code and less overhead. And yeah, it's still bring your own large language model running in the backend. That's the power of Teradata's Open Analytics Framework and bring your own large language model capabilities, giving you full control with open source models and simplicity via Teradata GenAI.
Thanks for that great demo, Janet. So before we jump to the Q&A, we encourage everyone to sign up for the free ClearScape Analytics experience. You can see the QR code on the screen. What you will, once you sign up and get in, you'll get the same experience as what Janet just showed you. Janet will tell you more about that, but we'll also let you know some exciting upcoming events. Janet?
Yes, please sign up by scanning the QR code that you see on your screen. You will make Jefferson and I very, very happy when we get notified that we have signups from today's session, as we will know that we inspired you to access our learning resources. You will also have the demo that I just ran through available for you to explore and request access to. I also want to take this moment to invite you all to our next week. We have an upcoming Industry AI Symposium happening from May 20th through 22nd, where we will be covering various use cases and AI applications across different industries, finance, healthcare, and telco. We will be joined, this event is put on in collaboration with Google Cloud, so please join us. You don't want to miss it. Now, before I jump into the Q&A session, I would love to ask you to please hit the survey button that is located in the survey engagement panel, and let us know what other live demos you are interested in. And we're ready for Q&A, Jefferson.
Hi, thank you, Janet. So I'm scanning through the Q&A list here. I see a couple come in. So let me read that and I'll try to answer that. Okay, first one. How do I know if my VantageCloud environment can run Bring Your Own LLM? So it's easy, really. So as you can see earlier, I showed you 3 patterns, right? So the 3 patterns gives you ability to run language model inference in different platforms. So what Janet just showed in a demo requires VantageCloud Lake. So if you're in a in a VantageCloud Lake environment, then you have the ability to stand up an analytic GPU cluster and run the Bring Your Own LLM use case. Now, if you're in VantageCloud Enterprise, now you will have the ability to also run the pattern tree, which is using BYO-LLM Onyx Onyx embeddings. You will be able to run embeddings and do vector store search from the output of the word embeddings. Now, one big thing that's also available if you're in VantageCloud Lake, and is when you when you want to use the cloud service providers inference services or AI services, that's available in Cloud Lake also, and it will later in the year it will also be available in enterprise and even on prem. So that's how you will how you can take advantage of this inferencing and text analytics models for your own AI use cases. Another question that came in here is, how much faster can I inference with GPUs? So GPUs is ideally the best way to do inference for language models. Now, however, there's the domain-specific language models are also capable of being run on a CPU platform at decent performance. GPU is always the best, but of course GPUs are scarce and cost more, and everyone has a CPU machine. So with Teradata, the advantage of Teradata is that it's a parallel system, which means that you have multiple CPUs and are used to run the inference. So in essence, your job will run faster than your laptop if you compare it that way. So because all the CPUs are used and optimized to run the language model inference. That's all the questions I see here, Janet. Oh, there's a late coming one. Okay, let me read it. So what are the costs associated with using Bring Your Own LLM? So Bring Your Own are actually not much more than a standard analytic compute cluster in a VantageCloud environment. It's only about, because we use in VantageCloud, we use VantageCloud Lake, we use metric or credit. So it's only about 20% more credits deducted from your account for every hour of usage. So that's 20% more cost, or even take the 4 times faster. So at the end of the day, if you're running language models, it's still cheaper to run on a GPU cluster rather than CPU. CPU is one good reason to use CPU is if you have already the systems that's available to you. Because as I said earlier, GPUs these days are scarce commodity. So you may not have GPU yet, but of course in the future you may have time to procure one. So at this point, your best is to do CPU, but with Vantage, you have the ability to use either CPU and recommend GPU if you want to the value and the cost, the lower cost you will incur. So that's all we have here from a Q&A, Janet.
Thank you so much, Jefferson, for taking those questions. We will be back next month with another live demo, so please tune in June. We'll be featuring our integration with Fivetran as part of the modern data stack. Thank you all so much for joining us. Until next time.